Hello, guys. Welcome again. Today is the day 5 of 100 Days of UX Challenge, and today we read the fifth chapter of UX of AI, UX for AI book. And this was really eye opening for me because it was about how AI is currently deployed in the real world and what are the matrices which are used to evaluate the AI. So we will start uh, with that. So in the world of AI, AI accuracy is meaningless in the real world. Okay. So what is AI accuracy? So if you see the Kaggle and everything, I'll show you. There is a data science competition called Kaggle. Uh, so they conduct a competition and they evaluate the AI models based on these parameters, but the precision and accuracy seems like a very important parameter there. But that's not how the AI world operates. So if you see, uh, there there could be like three kind of AI models. One is conservative, one is balanced, and one is aggressive. So now what is aggressive and what is conservative, what is balanced? See, uh, how many alerts they are sending. In conservative they are sending 10 alerts and there are 9 problem found. So conservative AI has like good precision, like 90% precision, and accuracy is also 88%. Whereas the aggressive AI model sends like 80 alerts and there are actually only 19 problems found in that. So the precision of that aggressive AI model is pretty less. Okay, so now just think about which is the best AI model out of this. You will say, okay, the conservative is the best because it has a best precision and the accuracy, but it's not the case in the real world. Okay, if you pick the best AI solely on the best data science metrics, your choice would be wrong. So why it would be wrong? Let's see this scenario. In this one, if you see, this is a conservative AI, this is a balanced AI, and this is the aggressive AI. Now see, it has a good precision in conservative AI, also the accuracy is also like really good. And but at the same time you are earning, your revenue is like $5,800, whereas in the balanced AI, if you see, your revenue is almost 150% of the former. So what is the catch here? Okay, now this could be the case in real world as well, where there are true negatives, false negatives, true positives, and false positives for any AI. What is false and true negative? Let's understand that case by one example. But now you are thinking that how can accurate AI be wrong? Okay, like how can this possible? Um, so let's understand by one example of a car. So suppose there is a company who is manufacturing cars and they have this AI model to let their users know if you need to change any parts or come to service, or anything, any breakdowns gonna happen. It will predict and let the customers of their car company know that okay, these are the problems and these are the alerts they get. Now there could be four kind of situations. Okay, so AI could be giving a true negative, like okay, there is no problem with the car and AI does not send an alert. So AI will get to a decision point where it has to make decisions. Okay, should I send the notification to that customer or not? So if AI decides that okay, I don't want to send because I don't think there is a problem in the car, so that's a true negative. Okay, so AI is right at that time. But there could be also a false negative where there is actually a problem but AI does not tell us. There could be the third possible outcome where there is a true positive. Okay, there is a problem with the car and AI sends the alert correctly. And there is a false positive as well. While the car is running perfectly fine, but AI still choose to send the alert to the customer. Now let's understand this better with a confusion matrix over here. So I'll uh, I'll make you understand this. So understand these are like 100 decision points for this AI. Okay, so in a car, AI is running 24/7. It's it is getting the data and everything, and there are like 100 decision points uh, which this AI has like reached in a year. Okay, in a year. Now understand this. What is this 80 and what is this 20? Okay, this is called actual no and this is called actual yes. So what is actual no and actual yes? So when there was actually no problem in the car, there were 80 cases. Okay, and when there was actual problem in the car, there were 20 cases. Okay, clear? Now let's understand how AI performed in that. So out of this 80, okay, when there was actually no problem in the car and AI at that decision point, AI actually was right 79% of the time. Okay, only one time it predicted, okay, there is a problem in the car. Okay, only one false positive was there. And see the second scenario where there were actually 20 problems in the car, but AI was able to predict only 9 times, and 11 times it just ignored it. Okay, it just said there are no problems in the car. So okay, now you have to understand that that's where AI accuracy and the nature of AI works here. How accuracy is counted? So see the correct prediction divided by total prediction into 100. So what are the correct prediction here? 79. So this true negative, this is like true prediction, and here is like 9 true positives. So 9 times they actually found out there is a problem in the car. So if you see 88% accuracy of this particular model, this is a conservative AI. Now let's see, it was good, but when you are out and running with a car, and if you miss 11 out of 20 problems, then there will be a problem for you. Okay, so this AI model might not be good for you. um, and AI trained on accuracy is often too timid. It tries too hard not to be wrong. Okay, so when the AI is too accurate, it tries that it shouldn't be wrong like most of the time. So it leaves money on the table. It means that it doesn't take any risk to okay, go ahead and tell the user that okay, there could be a problem. It will save themselves just because even if like it's not like 5 or 10% not sure, then it will not take any call. So that we need to understand like how we are choosing the AI model at the time. And while in the other extreme, so AI is trained on recall, tries to account for every possible positive. Okay, so when you train an AI for recall, which is often too aggressive for real world use. So sometimes when you don't need accuracy, but you want to be extra safe, you want to take some bets and all. So at that time, this other AI is useful. Now, when the conservative AI works best, now you have to understand like there are 10 alerts and problem found 9. So precision and accuracy was really good, and the recall was 45%. Here if you see the revenue of all these three models, the 60,400, the best is for the conservative AI. And why? Now you have to understand the mathematics behind this. Okay, so this is still an example of car. Okay, just think about your customers. So you are a car company, your customer is coming to service station every time. uh, or not coming actually. So that's a true negative, that okay, so you don't have any problem in the car, but AI has actually detected it. Okay, so you are saving $800 at the time. So that's why you are earning, as a company you are earning maybe $800. So in that case is you this revenue actually for your conservative AI, you are getting much more money in that case, because you don't have like much downside. So even if you are false negative and false positive, there are very less case in conservative AI. But mostly because it doesn't take any risk, conservative AI won't take any risk. So chances of getting it wrong is like really less, and there is a less downside of it, so mostly it will be right. Even like when the true positives are there, uh, it will like be very sure agar if it's positive, then only it will show that. Okay, so that is where the conservative AI works best. And the second one, when aggressive AI works best. Okay, now you see the conservative has like fallen down, it's in negative. But if you see the aggressive AI is making much more money. Now think about, so when I just thought about this example, I instantly thought about F1 car maybe. So if you are working on an F1 car and you want to be the best car in the world, right? So you don't have any budget problem or anything, you just want to be best in understanding your car. The you increase the performance of that car at any cost. So in that time, what you need, you want to see each and every scenario where you can have a problem. Even you can think of a Dakar race. Okay, so you have to go in a uh, in a like large vast deserts, and you have to cross the deserts with your bike or car or a rally car or a truck. Now even if even the call of the positive, like false positive, is more. If you see, this is 61 times it was false positive, but the downside was not that much, like it was costing $100. But the upside of saving that was like $10,000. So if you save any extra parts, okay, like there are so many costly parts used in cars and bikes, so if you can save them, then you are saving a lot and you are earning a lot at the same time. So every time when you are talking about value metrics and AI accuracy, you have to understand what are the incentive for you. Okay, if you get enough incentives, then you can actually discuss based on that, that which AI would be the best for your use case. And based on that, you can also, so there will be an exercise of doing that. So in my use case for this exercise, so I did this exercise yesterday for the focus clock. In that one, I um, so basically these are the smart glasses, and it's showing me like the focused version of you know my life. And for that I had to create a physical component of so basically this is a digital representation of the physical component of the system. So similarly I also did, like there is a smart glass camera feed, and there are also heartbeat monitoring, and then users data is also I am putting there. And maybe if I'm using smart glasses, it's near my head, so I can somehow get the brain activity information if I'm focused or not. And yeah, based on that I know that okay, my resting heart rate is this much, and I'm not doing any physical activity, then why my resting heart rate is this much. So it will give me some wellness feedback on the glass at the same time to the user, and it will be derived from a database. Now checking users response. So if a user is not responding uh, to your prompt, then it might be a problem. So it will check if user is responding, and based on that the feedback, the reinforcement feedback will be given. So what is reinforcement feedback? So it's like you are motivating them to do the good, what you say, good behavior strengthening. So if you are doing some good activity, then you want to reinforce that good habit overall. So that's how we can use AI there. And all the feedback is going back to the screen, so it's our primary way of interaction point. So yeah, this was one of the exercise. This was really useful to understand that okay, how deep you can think actually as a designer as well, even if you don't know anything about technicalities and all, but you know the basics, right? Like which sensor is doing what. So based on that also we can just understand like how system works. It gives you a better perspective to think in terms of how you, as a designer, you are part of this whole system and you are trying to understand everything. And although it's not necessary, but once you understand the complexities, you respect the organization you are working with or the product you are trying to create. So yeah, this is important. And for the tomorrow's exercise, so we have to create this AI model, and basically what we need to do is we have to understand the true negatives of our product, false negatives, true positives, and false positives. So um, we will write it down, and yeah, I will share that with you tomorrow. And this was really a good day for me, just to understand how this, I mean, I was completely unaware of all this AI related value matrices and all, and this was really eye opening that okay, accurate AIs are need not to be the best choice every time. You have to think about what are your incentives, what are where how what is the upside of guessing right, what is the downside of guessing wrong. And suppose if you guess wrong, then there is no downside, then you can choose aggressive model as well. So yeah, that's how you have to think. And the more you do this exercise, the more you understand that nature of the AI models. So yeah, thanks for joining in. This was a really productive day, and I mean, even if we have done not much, but I think it's better to register everything whatever you study in a day. So in that way, we have learned something, and this was a productive day. And we have successfully finished the fifth day of this challenge. Still 95 left. We are dedicated, and we will do it uh, no matter what. Yeah, thanks for joining in, and signing off today. Thank you.